algebra. We're moving on to CO5, which is all about equivalent fractions, which you have done since what, 4th grade? Right? We've simplified fractions, we've used equivalent fractions, but we're going to then launch that into the context of proportions, which I know you've also done because they were on your entrance review at the beginning of the year. So there should be no surprises today. More of like just remember, here's what we do, here's why we do it, here's how we do it, and that's going to kind of be a launch point for stuff we do later on in the year. So first of all, let's define equivalency. What is equivalency? What does the word mean? Equivalency.
It's like the same.
The same what?
Like the same amount. Yeah, amount.
Okay, not a bad word. What I'm looking for is starting with a V. Ends in LU. Value, very good job. Equivalency is two. I'll just put the same value. It doesn't have to be just two. Okay, the same value. So when you write an equivalent fraction, you are writing a fraction with the same value. We use the equal sign oftentimes, but it's not referring to like the numbers, because the numbers of equivalent fractions are different, but their values are the same. Okay, and so the key point here, you need to put on a help sheet. It says define equivalent fraction, multiply or divide both the numerator and the denominator by the same number. In effect, you are multiplying or dividing by 1, so even though the numbers in the fraction will change, its value will not. This is the important part here. Liam, Sawyer, catch this right here, okay? The reason why the values of equivalent fractions do not change is because really, you are multiplying or dividing by 1. And when you multiply or divide something by 1, the value doesn't change, okay? So let's just dive right in, because I think we've had this before. 3/7. Give me something we can multiply both the numerator and the denominator by.
2.
That will give us an equivalent fraction. 2. And when we do that, we're really multiplying by 2 over 2. Right? What does 2 over 2 equal? 1. And when you multiply something by 1, does the value change?
No.
No, it never has. Right? The numbers do. 3 times 2 gives us 6. 7 times 2 gives us 14. So the numbers change, but the value doesn't. Okay? Who's got a calculator on?
Me.
Take it out, please. This is how you can prove that equivalent fractions have the same value.
3/7. Do you have an extra calculator?
I do not.
He has a fat, chunky one.
I do. I guess, yes. I guess I spoke too soon. I do that too.
Thank you.
So what operation does a fraction represent?
Division.
Division. So in your calculator, I want you to take 3 divided by 7. 3 divided by 7. And you get approximately 0.423?
428.
428. We'll round that to 0.43. Okay. Now, take 6 divided by 14. And tell me what you notice.
It's the same.
It's the exact same. Okay? That's how you can prove that equivalent fractions have the same value, because when you divide them and you get that decimal answer, that decimal is the same. Okay? So equivalent fractions have the same value. How you can prove that? Did you do the division here? Did you prove?
Yes.
3 divided by 7? Okay, 6 divided by 14? It's that same decimal value. Give me another number we can multiply 3 and 7 by to make an equivalent fraction. 5. Fantastic. 3 times 5 is 15. 7 times 5 is 35. Just for kicks, go ahead and divide 15 by 35. And I bet you can guess what you're going to get.
The same number.
The same decimal, approximately 0.43. Okay, again, that's how you can prove that fractions are equivalent. So, what I would like you to do, and with only 10 minutes left, girls, with only 10 minutes left, this is just going to be homework for tomorrow. I want you to, what?
The whole thing?
If you just let me
Finish his sentence.
Yeah.
Okay.
Like, I took a breath and you're just jumping down my throat. So what I want you to do is for 8/10, I want you to show me what you are multiplying and dividing by. So let's take one with multiplication, one with division. Madeline, what do you want to multiply 8 and 10 by? 2. So I want you to show me you're multiplying by 2 over 2. I want you to show me what that equals. Okay? 16/20. Now let's do one with division. What can we divide 8 and 10 by?
2.
2. Show me you're dividing by 2 over 2, because dividing by 1, does the value change? No.
No.
Same with multiplying by 1. Show me what the new fraction is. 8 divided by 2 is 4. 10 divided by 2 is 5. And then I want you to write the decimal value of what these 3 fractions all are. What do 8/10, 16/20, and 4/5 all divide to be? Melanie? 0.8, and you can put that right up here. So it's not just writing 2 equivalent fractions and you're done. It's putting in the work. Just the remaining 6, Ava, for tomorrow, not the whole thing, just the remaining 6. But you do have to show the work on how you find it. And if you're like, oh, I did this in 4th grade, you did. Okay, but this is going to be the launching points. If you're, it's a good thing just to review. Okay, before we hit into how we're going to use proportions in the context of pre-algebra. Questions on what I'm asking you to do? You've got 8 minutes to work. Questions on what I'm asking you to do for tomorrow? Just these 6. Just these 6. Okay. Just these 6 for tomorrow. We will do the next page tomorrow, but homework for tomorrow, just these 6. Do you think we can play the number game for realsies tomorrow?
Yeah.
I sure hope so. I sure hope so. Okay, alright. That's it, math, folks.
Don't forget to like and subscribe.